Welcome back, guys. This is our next step here. We have section 3.2 still, but we're talking about molar mass this time. And we've been mentioning this before, but anytime I have a mole, it has some mole of atoms. It has some sort of mass at the end. For example, we've been mentioning that 1 mole of oxygen atoms is weighing 16 grams. And our periodic table has all this information here. And I have a couple others. On your periodic table, if I look at sulfur, it has atomic mass of 32.1, and you can imagine if I had that many sulfur atoms, it would weigh that much. Same thing, if I had 1 mole of mercury atoms, 200.6 grams. If I had a mole of iron atoms, it would be 55.8 grams. So that's the word molar mass. Couple details about this. Sometimes in the questions that you're going to be getting, they're going to be asking you for a formula mass versus a molar mass, or it might even mention molecular mass. And here's formula. So let's get a couple details figured out. One, the word molecular, if you remember from chapter 2, that meant it had covalent bonding inside of it. And if it is covalent bonding, it is going to be a molecule at the end. For example, water is like this. So it is very tiny inside of its mass, extremely small. So we have to use the letter U for its unit, and that represents atomic mass units, extremely small. Same thing for formula mass. Formula mass is ionic inside of its bonding. For example, sodium chloride, that's a positive sodium attracted to the negative chlorine. This is extremely small, this tiny little unit that's boxed here. So that means we have to use the unit U as well. Anytime you hear the word molar, though, molar mass means a mole of those atoms. That means 6.02 times 10 to the 23rd atoms of that. So this is going to give you an actual measurement that we can see on our scales called grams. All right? So that'll be the little details. Let's check out page 119 together and see the details of this. Okay, so in this little frame here that's shaded in, remember, molar mass always in grams because that's measured, it's a mole of it. Anytime I have the word atomic or molecular or formula masses, that's the atomic mass units, so U's. Okay, so let's try this one. We have aluminum sulfate, and we're looking for first the formula mass, so that's going to be in U's, and then molar mass. You need your periodic table for this to make sure you get it figured out. So my formula says aluminum, there's 2 atoms of it, and that's why I put the little 2 here, and then 27.0 is its atomic mass on the periodic table. So I multiply those together. And then I distribute the 3 through here to sulfur and to oxygen. So 3 sulfurs, 32.1 is my atomic mass on the periodic table. And then 3 times 4 oxygens that are inside of there is 12 oxygens total, and 16.0 is its atomic mass. Add all of these guys together, I get 342.3 U's. Molar mass would be identical inside of everything else, except your units are in grams, and then at the end you would have grams. Let's try number 1 together here. I am looking for the molecular mass of nitrogen dioxide. Hopefully you remember that nitrogen dioxide is NO2. And molecular mass means my answers has to be in atomic mass units. So let's set it up just like we have. So in my formula I have 1 nitrogen, and nitrogen on the periodic table is 14.0 U's. And then I'm going to add it together to 2 oxygens, 16.0 U's. And then I just do my math. So 14 plus 32 gives me 46.0 U's. So that'd be my molecular mass of nitrogen dioxide. Please do number 3 here. The molar mass of iron 3 sulfide. Figure out that formula first. And molar mass, remember, should be in grams. All right, give it a shot.